All right, let's put ourselves in the shoes of someone who is trying to decide what major to take in college. And we're going to build a model really explicitly around, them, trying to give them the actual tools they would need. Someone who doesn't necessarily know how to program, we want to give them a model that they can use. So first and foremost, the earlier examples we gave are a little contrived. It's not as if someone's going to look at every single degree program and based on every single degree choose what they're going to do only based on an unemployment rate and salary. Rather, people have personal preferences regarding kind of which subfields they might be most interested in. So, for example, some people might be really interested in law, others might be really interested in communications, but they may not have settled on any one particular topic. It might be someone is very interested in the humanities and arts. Someone might be very interested in social science and psychology. So we don't want to necessarily force a user to pick one category, but we do want to give them the flexibility to, for example, remove engineering or remove health or remove physical sciences, things that they know they are not interested in. So first and foremost, let's define down here a new variable, and we are going to call it choices. And these will be the choices that an individual makes. And for now, let's just put 2 choices. So I'm going to put brackets here because we're going to define a list of choices, literally a list. And in quotes, we're going to put 3 of these major categories up here. So in this case, I'm going to put, let's see, what is the most natural thing for data science at a liberal arts institution? We'll do humanities and liberal arts, we'll do computers and mathematics, and we'll do social science. That sounds good. So let's go ahead and type these in. So literally, they just need to be the same as in that list above. Arts, and then we said we would do computers and mathematics, and then we said we'd do social science. Okay, so I'm going to go ahead and run this just to define that list. And now what I want to do is I'm going to create this figure, but I'm going to limit this figure to only those 3 choices. So first, just to be safe, I'm going to re-import this Plotly. So down here, we'll do an import Plotly again. And then we'll go ahead and do the same plotting we did before. So we'll create our figure. We'll just call it fig for short, equals px.scatter. And then what you'll remember is up here, let's take a look. So to create this figure with every single major represented, this was the line of code we used. So I'm going to copy this, and I'm going to paste it down here. Well, again, I'll just rename this fig for the sake of making it easier later on. So the same x, right? We still want the same x, we still want the same y, nothing's changing there. We still, when we hover, want to be able to see what the major is, so this won't change either. We can keep the color by major category. Really, all we want is we want to remove all of the major categories not on this list. So to do that is pretty straightforward. All we have to do is change the data that we are putting into the scatter plot. So to do that, we put brackets beside that, so df and then brackets, and inside these brackets, we have to tell the algorithm which rows of data to choose and which rows of data to ignore. So to do that, we're going to type in df again, dot major category, and then dot is in, and then in parentheses, choices. And so before I run this, I'm actually going to copy this here. I'm going to paste it down here and just run it outside of this so you can see exactly what this is doing. So when I run this, what it does is it goes through every single row of df, and it says, is it true that that row's major category is in this list? So you can see if we go down to row number 12, that's the first time it's true. So let's actually look at df. I'm going to go down again, I'm going to type in df, and let's look at, if we scroll down to the 12th case, we can see, where are we? Here we go, humanities and liberal arts. So we'll remember on our choices list, we had humanities and liberal arts was one of them, and that is the first time, observation number 12, where we actually see something in humanities and liberal arts. Everything before it is agricultural and natural resources, as well as engineering, which we didn't choose either of those. So it's just saying that that row is truly in the choices that we made. So when we then say, okay, df bracket that, what we're saying is df bracket trues and falses. So every single time that it's false, we're going to ignore the row. Every single time that it's true, we're going to choose the row. So this is very similar to the selection that we did in lab 2, lab 3, the previous lab. So I'm going to go ahead and run this. Now remember, we do have to do the fig.show. And this should show us the same figure as above, but with only these three categories. And here we go, right? So this is identical. There's nothing fancy here. It's just we've now subset our data set down to only those three categories. So now someone who was interested in these three, they could, quickly kind of assess which ones within their kind of more specific subfield would be most interesting. So, a user would probably want something like this: the beautiful mathematics and computer science, which has a very, very low unemployment rate and a very high salary relative to everything else. So again, this helps us to subset down to a more, intuitive type of data display, but we really want to actually make this algorithmic so that individuals can choose kind of what major they would want based on 3 bits of input data. First, we need to know what their kind of preferred unemployment rate is. Second, we need to know what their preferred salary is. And third, we need to know what their preferred major categories are. So the next goal we have is to actually programmatically take those 3 pieces of data in and then automatically kind of provide them with their top 5 choices. What are the top 5 that would be most appropriate? So for example, this user, let's say that this user, the maximum unemployment rate that they wanted was 0.05. So they really want to be somewhere around 0.05. And then they also want to be somewhere around $100,000 in their 75th percentile. So around this point right here, of these 3 major categories: humanities, computer and mathematics, social sciences. So you're right here on this particular scatter plot. If you're right here, then the 3, 4, these 4 cases are all very, very close to where your preferences are. And so you would computer science, mathematics, information science, computer and information systems. That's where you would be. And so these are the types of degrees that you might be, most interested in, because they're around the salary and unemployment rate that you want. We want to build the algorithm that can do that for us. So it'll actually give us a list of these 4 based on what my preferences are. So let's go down here and go ahead and define that. So first we're going to do our choices again. I'm just going to copy and paste these choices. And I'm also going to go ahead and copy and paste this import plotly, just again, so we always have it just in case. So same choices. Now we actually need to define, though, our preferred unemployment rate and our preferred median salary. So we'll actually call that, just to make it very, very straightforward, preferred unemployment. We'll call this unemployment. And let's do the same thing we just did, so 0.05. So again, we're looking for jobs around this particular level of unemployment. And then preferred median salary. And let's set that same we did before. Let's set it around 100,000. So we're going to be looking at these points right here. So 100, 1, 2, 3. So what we need is an algorithm that when we put a point on this particular scatter plot, it actually then identifies the closest points. And that, fortunately, is a very, very straightforward algorithm. In fact, it's so straightforward, we're going to write it ourselves. It's something called a nearest neighbor. You'll probably remember at some point you took a trigonometry course where you learned about the Pythagorean theorem and how you could calculate the distance, of different things based on their Manhattan distances. You get Euclidean distances, so on and so forth. We're going to do that. So we're going to be going all the way back to high school trig. So let's write our first algorithm. And this is actually going to be the algorithm again that takes this stuff in, all 3 of these bits of information, and outputs a list of what are the closest majors to your preferences. So first we're going to define, here we go, nearest neighbors. And you can call this whatever you want, just remember it. Because if you don't remember it, then it's going to cause trouble. This is the algorithm. This is the model that we are going to be using to kind of provide that information back. In parentheses, I'm going to call this the data frame. So we'll call it NN_DF. You can call this again, whatever you want. I'm going to call my data frame NN_DF for nearest neighbor data frame, comma, max unemployment, or preferred rather, so pref unemployment, and then preferred salary, so pref salary. Again, you can call those whatever you want, just remember. So these are 3 variables that I can use these variables inside of this function. Anything that's inside of this defined function, it can use these variables. These variables don't exist outside of this function, so they're only within it. And here what we're going to do, just to show you what's going on, is I'm going to print pref unemployment. And that's it. I'm not going to do anything else. So now, outside of this function, so you'll see down here, I'm going to type in typing. See how I typed in this word typing, and it's no longer tabbed over. So print is tabbed over. It's kind of underneath defined over here. What that tab means is that this is inside of this function. So this print will only happen when I call this function. The fact that the word typing is over here means that it's outside of the function. It's no longer in the function. So this will get run as soon as I run the code. So let's go ahead and run just an example of this. So I'm going to do nearest neighbors. Inside here, I'm going to put in, so the first thing I have to put in is my data frame. So let's scroll all the way up, and you'll remember this is actually how we write in our data frame. I'll go back down here. We don't need that right now. We don't need this right now. So we're going to import up here, pandas now. And so now we're going to read in our data frame, pd.read CSV, and this is the actual data frame. And so the first thing I'm giving nearest neighbors, because the first thing I set up here is that this should be a data frame. So I'm going to type in df. So that's where my data frame is going to go, comma, pref unemployment. So pref unemployment, we want to set equal to this preferred unemployment rate, so this 0.05. So we can actually type in here if we want 0.05, or we can delete that and we can copy this and put this here. And it'll be the same thing either way. Because preferred unemployment rate equals 0.05, it's the same thing. Preferred median salary, so I'm going to copy this, comma, and put that here. So you can see the order is the same. NNDF is going to be equal to DF. Pref unemployment is going to be equal to preferred unemployment rate. And pref salary is going to be equal to preferred median salary. So when I run this, remember, preferred unemployment rate, it becomes, when I call this function nearest neighbors is going to go in, and it's going to say, okay, the first option here is DF. So now NNDF for me is equal to DF. Pref unemployment for me is equal to preferred unemployment rate. So when this particular function says print pref unemployment, it's going to print the number 0.05 because we're putting it into the function. This obviously seems quite convoluted, right? You may be thinking to yourself, why would you ever bother with this type of a function? But we'll get into that in just a few minutes. So let's go ahead and run this and just make sure it does put out 0.05. There we go. So the function beautifully printed out 0.05. Now, we're going to do one quick thing to this particular function to make it a little easier to understand what's going on. So here, I'm going to actually say, okay, nn_df. So nn_df equals data frame. And then I can hit enter after this. And I'm going to do pref unemployment equals preferred unemployment rate, comma, pref salary equals. And so you can see within the function, nearest neighbors, it's just more explicitly telling us what each one of these will become. And this will still print out 0.05. There's no difference here. It's just to make it easier to understand what's happening. So now let's just add up here in our function. Let's add one more print. So print pref salary. And we're going to run this again. And now look, it's printing out both of those things because this is where we're calling the function. We're saying, go ahead and run my function. This is what we're actually going to output in terms of the data. And because we added that print in the function, it's going to print whatever is defined as pref salary. So now what we actually need to do, though, is change this function, this nearest neighbors function, so that it is going through and calculating the distance between our desired point. So you'll remember 0.05 and 100,000. So about right here is where we want it to be. We have to calculate the distance between that point and every other point because we want to find the 5 cases that have the shortest point. Now there's a lot of algorithms to do this. This is a very common class of problem. But we're going to use the kind of simplest one, which is we're just going to go iterate over every single point. We're basically going to say, okay, let's hypothetically say my preferences are 0.04 and 80K, right? So I'm going to put an imaginary point right here. I'm going to calculate the distance between that imaginary point and every single one of these dots, and then I'm going to pick the 4 shortest ones. That's all we're trying to do. So let's get rid of these prints because we don't need them anymore. And the first thing we're going to do is to define something called a for loop. So I'm going to type in for I, and don't worry about this for this moment, in range 0, len nn underscore df. And then I'm going to put a colon after that. And then down here, I'm going to type in print I. So what that's going to do is it's going to say, I'm going to repeat this function over and over and over again for all values of I, where I is defined as a set of values that is this long. So if I run just this, I'm going to copy this down here, this range 0 len df. If I run this, you'll see that this is actually, I have to do this as normal df. Remember, the reason I got this error is because nndf, you're only allowed to use that in the function. I can't use it outside of the function, so I have to use df outside of the function. So you see this range, I have 173 values within df. So nndf, because nndf will equal df in our function, it'll have the same thing. So it'll go, okay, I equals 0, I equals 1, I equals 2, I equals 3, so on and so on and so on until it gets all the way to 173. So the first time I run this, it's going to print out a list where I is 0, 1, 2, 3, 4, so on and so forth. So let's go ahead and run this, and voila, it's done exactly that, right? It's printed out this list where every single value of I is incrementing. What we're going to use this for is we're going to assign every single one of these points a number. So like this might be point 0, this might be point 1, 2, 3, 4, 5, all the way up to 177. We're going to then take that information and we're going to use that to calculate our distances. So how do we do that? First, what we want to do is inside this for loop, we're going to define a new variable for a given row of data. So for example, let's say that we're looking at the row, which is mathematics and computer science. We want to have a new, within that row, we want to have a value that is the distance to whatever point we are, kind of our preferences are at. So if we want the 0.0490k, we need a column of data that tells us that distance is equal to that value. So this gets a little bit messy, but we're going to walk through it very slowly. So first we have the nndf dot at. So first we need to look up which row of data that we're actually looking at, because all we have is this number I, right? So we know that we're looking at row 0, but we have to actually tell the algorithm what row 0 means, because the algorithm doesn't inherently know that. So we're going to do a dot at, and that says to look at this particular area. And then in brackets, we're going to do, again, nndf dot index I. And what this says is to look at the first, the ith row of data. So if this is equal to 0, it's going to look at the first row of data. If this is equal to 1, it's going to look at the second row of data, so on and so forth for those particular indices. Then we want to look at a column that we're going to create called distance. So we're saying look at the let's say I is equal to 100. We're going to be looking at the 101st row of data, and we want to look at the column value for that row called distance. And this is actually what we want to calculate. So for every single row, we want to calculate that value. Now we're going to go to good old-fashioned trigonometry. So as you'll see on the screen, we basically just want to implement that this equation that tells us how far away one point is from another point. And we can do that by calculating, because we can easily calculate the kind of north-south and the east-west from a point. It's very easy for us to get that final distance. So I'm just going to type this equation in. Square root. We're going to take our max unemployment, or the preferred unemployment, and we're going to subtract from that and you'll see something very, very similar here, and I'll explain this in just a moment. Okay, so this is the first part of the equation where we're taking our preferred unemployment. That is basically where we're going to be on the x-axis. So let's say that my preferred unemployment is 0.03. So I have a point right here. And let's say I'm looking at how far away I am from this point. All I'm doing is I'm subtracting these two values from each other. So I'm going to get a value around 0.01 in that particular case. So I do that preferred unemployment. I do that particular subtraction. And then I'm going to square it as per the equation. And then I'm going to do a plus. And then down here, we're going to do the same thing. So, oh, excuse me, we have to get rid of this particular parenthesis. We're going to do that later. So plus. And then the same thing. So medians, the salary preference. So pref salary minus NFDF dot LLC dot index I same times 2. Okay, so this is essentially the equation. So we're manually specifying this equation to find the distance between 2 points. So the only kind of programmatic thing here that you may not have seen before is this dot lock. This is essentially the exact same thing we're doing with dot at in this case. So dot at lets us set a variable. Dot lock it, we're looking up a variable. You can actually use these interchangeably in some cases, but this is just saying look at this location in the data frame for this particular index value, the whatever I is. Look at that unemployment rate, and so we're going to do that subtraction. We find out what that subtraction is, and then we square it. We then add that value, and one more parenthesis here just to make it easier to read, to the preferred salary minus the same thing, except this time we're taking the median salary, and then square that as well. And then we do take the whole thing and we take the square root, and that will give us what that distance is. All right, so we're almost done, but now we have to tell the function what to do after it's done doing this. So just, to make sure you can see it, I'm going to scroll to the right. So this is under 4i. So you can see I scrolled to the right. Here's our defined function, just so you can see all the text. And you can see here's the equation that we're running for that distance calculation. So we want the function to then return at the end of the day the new data frame that has this new column of distance that's calculated based on this. So I'm going to hit enter here, and very importantly, I'm going to hit backspace one time. And so you can see my cursor. If I type in something now, typing you can see that now it's at the same level of indentation as that for loop. If I then type return here, so I'm going to type in return, and in this case we'll just do NNDF. If I do this return, that means that after the for loop completes, every single one of these is calculated. It will then, the function, give me back NNDF. So nearest neighbors, this call will become equal to NNDF. So I'm going to go ahead and run this. And because this is now NNDF, it's actually going to print it out down here. And this is our nearest neighbor data frame. So you can see here, we have all of our different majors are still here. So the distance values have been calculated. Now there's two big problems. First and foremost is the one of the biggest problems is that all of these values, you can see they're enormous values, right? The distances are really, really big, but our unemployment rates are really, really small numbers, and so you kind of have to ask yourself what's going on. Why is this the case? It's because distances are being dominated by the median salaries, right? The fact that median salaries are in values that are in the hundreds of thousands and unemployment rates are in the values that are in 0.0 something or another means that a change in distance and unemployment rate doesn't matter nearly as much as a change of distance in dollars. So for example, a $1 change is equivalent to going from an unemployment rate of 0 to 100%. And so we're unintentionally, when we're calculating these distances, giving an enormous weight to salary and very little weight to unemployment rate. So the first thing we'll need to fix is that we actually need to standardize our different dimensions in order to make sure that we're weighting, a change in dollars equal to a change in unemployment rate. And there's dozens of different ways to do that. We're not going to go into any real detail in this course, but you can do a lot of different standardizations. The second problem we have is at the moment we're ignoring their choices, right? So we still have to add into this code a mechanism where we actually pay attention to what their choices are. Right now we're just kind of looking across everything. The last thing we're also going to have to do with this code is identify, now that we have this distances column, the top 5 shortest distances. That is the top 5 that are the closest. So we're going to work on the code to do those 3 things next.